Donc maintenant, place à la présentation de Gideon je m'excuse d'avance. Olugbadieye, étudiant au doctorat. T'es-tu pas si pire?
Good morning, everyone. So my name is Gideon Olugbadieye. So I'm being supervised by Fabio Generetti, and this morning I'll be making my presentation on the title Monitoring Esker Boreal Forest Response to Hydric Stress using Ecophysiological Measurements. As we all know that for trees to grow, we need the sunlight and the precipitation. However, in the context of climate change, where there's a possibility of having low or absence of precipitation and increase in temperature, so some of the challenges we will experience, for example, in a study site, in a site that is made up of gravels and of course when rainfall and it might easily infiltrate like esker. So some of the challenges we might observe will be low water availability. And with low water availability, we all know that such a tree will definitely respond due to low water availability. So in the context of climate change, trying to understand the way our trees respond, we believe a monitoring process is definitely needed. And one of the interesting monitoring processes with which we could monitor the response of our tree in the context of climate change is using an ecophysiological measurement, such as the sap flow. Just to give you a short understanding of how the tree itself works, we all know the tree takes water from the roots, passes through the trunk in form of a sap, and then goes out through transpiration. But by installing a sensor, which is the sap flow sensor, we can definitely have some basic information about our tree. And some of the information we can definitely understand is how the tree itself, the tree water use being used by the tree. Not only that, we can understand the tree growth condition, and not only that, we can understand the dynamics of the transpiration and its relationship with meteorological information. So basically having understanding like with the ongoing with climate change and the possibility of a site that does not really retain a lot of water, the tree itself might respond. We believe it's kind of really important to understand the way tree responds to stress using ecophysiological measurements and also its relationship with meteorological information. So with this, I have an objective, just one, so because I'm here to present my preliminary results. So the basic objective of this presentation is for us to understand the sap flow dynamics, sap flow density dynamics at different time scale, looking at it at hourly scale and also on daily scales, and basically its relationship with meteorological information. This study was conducted on the St. Matthew's Berry Esker in Abitibi-Temiskamai. And on our study side, we have the two study side, which is the top of the esker. What really distinguishes the top of the esker is really dry compared to the base of the esker, which is the second study side. The top of the esker is dry and is very, when waterfall is really infiltrate, and the base of the esker is not dry compared to the top, and also is very close to groundwater recharge. And these two studies I will be looking at the way the trees on the esker itself respond. So to get information about our sap flow density and the way it behaves, we have our sap flow sensor installed on the side. So at the top of the esker, we have 3 sap flow installed on the trees and also at the base of the esker. And this sap flow sensor definitely registers information in the sap flow data logger. So every information on the movement of the sap in the tree is basically being recorded every 10 minutes. And 200 meters not far away from the site, we have a big meteorological station. And also at the study site, we have 2 micro stations that was installed. So now I want to take you through the preliminary results I've gotten so far. So when we look at this result, we could see like on the hourly basis, looking at the base of the esker, we will definitely see that there's a kind of, at the peak, we have where it has the maximum transpiration is always between 3 o'clock. And comparing the early growing season at the base of the esker to the late growing season at the base of the esker, we'll see there's a kind of a little slight decline in the sap flux density Also, looking at the top of the esker horizontally, there's a kind of a decline in sap flux density during the late growing season. And comparing the two sides, although it's a bit really slight, looking at the mean maximum hourly sap flux density, so we could see from this image that there's a kind of a decline in sap flux density during the late growing season. Not only that, when we look at the response and the sap flow characteristics on a daily basis, during the growing season, we could see there's little, or the top of the esker and the base of the esker during the early growing season has almost similar patterns in the movement of the sap flux density. And looking at the base, comparing it now during the late growing season, which is between July and September, we will see that there's a kind of a difference between the esker at the base and at the esker at the top towards the mid of the growing season. We will see where the red box is over here, that there's a kind of a slight decline at the top of the esker while compared to the base of the esker. Also, one thing as the objective also say that I like to understand the relationship between the sap flux density and the meteorological information. So looking at the base of the esker during the early growing season, we'll see like with all the meteorological information, the air temperature, solar radiation, relative humidity, and the vapor pressure deficit, there's a strong correlation with all of them, but the VPD has the strongest positive correlation, while the relative humidity has the strongest negative correlation. Also, similar at the late growing season between July and September, there's also a strong correlation with all the meteorological information. Looking at also the top of the esker, we'll see that during the early growing season between May and July, solar radiation and vapor pressure and the VPD has a very strong correlation with the sap flux density. And at the top of the esker, at the late growing season, that was July to September, there's also a strong correlation with all the meteorological factors, but the solar radiation itself is more correlated compared to other, which is positively correlated. So, in summary of all what I've presented so far, we could see like hourly that the sap flux density, the sap flux density shows that there's a difference between the early growing season and the late growing season. And also when we look at it at daily, towards mid-July, as we could see in the earlier graph, at the mid-July, there's a kind of a slight decrease in the sap flux density at the esker at the top compared to esker at the base. And also looking at the relationship, there's a strong relationship with the meteorological information, the air temperature, relative humidity, compared to the sap flux density. So in conclusion, as I said, this is a preliminary result. This study definitely has provided us for us to have a better understanding of plant water use on the esker side, although there's still more analysis to be done, and we believe like by the time we have the result, we'll be able to have a tool that could be effectively used for forest management in the context of climate change. Thank you all for listening.
Thank you, Gideon.